A ball is thrown vertically upward with a speed u. Find distance covered during the last 3 seconds of its ascent. Ascent meaning the upward motion. So if we take, this is the upward movement, say the starting point with velocity u, be the final position, that's the final position where the ascent is finished. After start falling down descent. The final velocity at the topmost point will be 0. The initial velocity with which it is thrown is u for the complete motion, starting from throwing point till the highest point. Now we want the distance covered within the last 3 seconds of its ascent. So C to B will be the last 3 seconds. If total time from A to B is certain value, the C to B will be 3 seconds less compared to that. So you are supposed to find C to B. C to B is H. The total time for AB that we can find, or we can take as T1. So the time for AC will be 3 seconds less. So the last 3 seconds will be T1 minus T. So if we check CB, what all we know the details. Final velocity is 0. Acceleration due to gravity in the downward direction minus v. The displacement, what we need is upward h. So you can use the formula v square equal to u square plus 2af. That's the only relation where v and s comes together in a relation. But the only problem is we don't have u in that. Out of the three relations, v equal to u plus ac, s equal to ut plus half ac square, and v square equal to u square plus 2s, v and s comes together only in the last relation. The last relation, v square equal to u square plus 2as, in that you need u. The u for CB meaning it's a velocity at c. So if we can find the velocity at c by any other means, we can find the height using the formula v square equal to u square plus 2as. So this is equal to 0, u is Vc, plus 2 minus g, where is h. So 2gh will go left side. So Vc square equal to 2gh, or h equal to Vc square by 2g. So you can find the value of h by getting Vc square. So for finding Vc, velocity at c equal to u plus at. So u is u, velocity at c we don't know, a is minus v. The time to AC is t1 minus v, where t1 is the total time for AC. So this we are considering is. So in that we don't know what's t1. t1 we can find considering A. We take complete AB, u is u only, v is 0, a is minus v, we need time. total time T1. So substituting in the formula, V equal to U plus AC, 0 equal to U minus T into T1. So GT1 equal to U, or T1 is equal to U by. So T1 is the total time taken to move from A to B. So if you substitute the value of T1 here, you get U minus G into bracket U by G minus. You open the bracket, U minus G into G get cancel U. Minus G into minus G will be plus G. So this U get cancelled. You get velocity of C as G. Now you can substitute the velocity of C here. In that case, the X value will come as V square T square by 2G. So 1G get cancelled, half G. So the only point to be clear, we have to analyze the sections CB where you need to find H. Once you analyze CB, you have V0, A minus B, S is H, what you find. So from these two, V we have, and S you need to find. That indicates the last relation, V square equal to U square plus 2AS is to be used. For that, we need U. So that U is the velocity at C. That's the clue for next step. You're finding velocity at C using AC. Now AC, we have initial velocity U, acceleration is minus G, the time taken till C. The total time is T1, AB. So the time of C to B is the last 50 seconds. This is total 10 seconds and this is the last 2 seconds. Then this will be 10 minus 2. So here no values are given, so total time is T1. If this time interval is T, the time taken from A to C will be total time T1 minus T. So we are substituting U is minus T, T1 minus T. T1 is the total time. The total time is finding from only A to B, the total time. For that initial velocity we know, final velocity we know, acceleration T is our demand. So using V equal to U plus AC directly, you get 0, U minus G T1, so you get T1 equal to U by G. This value of T1 we are substituting here back. That's how we get Vc equal to U minus G into T1 will be U minus U by G minus. When you open the bracket, will be G. And substitute the value Vc back here in this equation, you get the final expression half G.